What's up, guys? Back to Mr. Allen's math class.
So we are questioning whether or not the $100 that I spent on the Green Timbs is really worth it. Okay.
We
so
don't think
I wear
it is.
them.
We do not think
Christmas
it is.
Eve and Christmas.
Yes,
all
sir.
right. I also get a little bit of St. Patty's out of that one. You know, right around
okay.
that the week before here in school, get a little green fit going.
Yeah.
And I usually wear them about twice. Okay. In school leading up to the holidays. Okay. So that's 5 times. Okay. And I bought these things, I think 6 years ago, the Green Timbs, 6 years ago. That's 30 wears. That's 30 wears. 100 divided by 30 is $3.33. Okay?
Per day?
Now, per wear so far.
Sorry, yeah,
per
yeah.
wear. Now, hold up. We are in rational functions, yes? So the cost of the Timbs, we'll say, as a function of wears, maybe I could do W, X, whatever, all right? They cost $100, but every time I wear them, the cost goes down. Now, if X were to approach infinite wears, right? As X approaches infinite wears, the cost of these boots is going to approach 0, right? These are basically free the more that I wear them.
Right.
That's what I'm saying. That's math, baby.
Is that the end of the video?
That's the end of the video.
Clap it up, Tony.
Clap it up.
Yes, sir. Yes, sir.
So I want to keep mathing up that situation from class. We were calculating the real cost of my green Timberlands that cost $100 up front. But every time I wear them, we said, hey, the cost of those boots goes down per wear, I guess, right? So we made a cost function, C of X equals 100 divided by X. And I got that plugged in my TI right now, and we're going to graph it and do some things with it. But first, I think it's best that we adjust our window to fit what we really want to talk about here, right? So my X minimum, the X is the number of wears, right? I can't wear these boots a negative number of times. I could not wear the boots. That would be 0. And then every time after it's 1, 2, 3, 4, right? Cool. So positive numbers. And in class, we did like 30 wears, I think. So I'm going to go further than that though. Let's go to like 100 wears for this one. Okay. And then if we want to adjust out further, we can, but I think that'll give us a decent window. The X scale, I'll leave it as 1, but my Y minimum, okay. Could I ever get to a negative cost? No. Could I ever get to a 0 cost? We talked about that. It would approach 0, but never really get there. I'll throw 0, though, for my Y minimum. That should be good. And then my Y maximum, logically speaking, if the initial cost was $100, that's the most it's ever going to be, right? One wear, $100 for that wear. Cool? So 0 to 100 for both of those. Now, let's graph this thing. And I get what looks like a rational function, or at least a piece of a rational function, that first quadrant there. Had I gone with, and let me show you guys, had I gone with negative 100 here and negative 100 for my Y minimum, and then I'll put it back, hit graph, you can see that, you know, it looks like almost like the parent function, right, of a rational. It just got 100 in the numerator instead of 1. Okay, so back to my window. Let's go to 0 for that. Let's go to 0 for the Y minimum. Hit graph. There we go. This is what we're really focused on because we're talking about positive number of wearing the boots, right? Positive numbers of wears and positive amounts of money. So I want the first quadrant. That makes sense in the context of this problem. Now, here I have, when will the boots cost $1? Well, you could probably do this in your head, right? If I wear it 100 times, if it costs $100 and I wear it 100 times, that's my cost as a function of X, right? That's going to give me $1. So after 100 wears, after 100 wears, they cost $1, right? Per wear. That's at least the thought process behind it, right? Hey, the more I wear it, the cheaper this is because I wore it more. They were still $100. Let's remember that. They were still $100 regardless of how many times I wear them. Okay. So how about when do they cost 30 cents? Okay. Well, we could check this out. We could go to our table here. I'm going to go table set first. And let's start at 0. We're going to change by 1, and it's going to be auto and auto for these things here. So I hit second window to get to table set, and now I can go to my table. And as you can see, we have an error there at 0, right? Because there's an asymptote there. There's a vertical asymptote at x equals 0. And as I go down here, I'm going to, get smaller and smaller numbers. And when we get to 100, we should see that 1, right? Oh, dang, that was pretty good. I don't usually stop perfectly like that. It's like when you're, filling up gas, right? And you perfect gallon amount or perfect dollar amount. That's a more painful experience though, right? Paying for gas, but this is an exciting experience. Okay. So I could keep going until I find, 30 cents in that right-hand side, but there's another way. Let's go to our y equals, okay? Go to our y equals. and I can put in 0.30 or just 0.3. Right, and then we'll graph this thing, and you can see that line right there. We can find the intersection of those two. Hopefully they intersect here, but I may have to adjust my window. Let's see here. Second, calc. Let's go to intersect. Hit enter. I got my first curve, that's the blue one. Second curve, that's the red one. That's kind of nice how it's like color-coded. And then I'll guess. I know there's only one intersection here, so I don't even have to arrow close to anything. I'll hit enter. Okay, so we do need to adjust that window, I think. All right, so let's quit. We'll go back to our window here. I'm going to adjust my X max. I'm going to go to like 1,000, you know. We'll graph it. Now, let's see your second calc, intersect. We're going to hit enter on the first blue one, second one, hit enter again. Boom, there we go. Okay, so it was out at 333.3 repeating. So between 333 and 334 wears, the price is 30 cents. So 30.30 cents per wear. Okay, so it's important to think about these things in the context of the problem and writing things down with those proper wordings and such as, right, with the right vocabulary. So cool, awesome. You can use another line, intersection, to find that in any situation here. We might give you other situations with rational functions where you have to solve and figure out a particular value. Okay, so the intersection tool with a second line is great. Now, what about this? What is a realistic domain and range for this situation? So, well, my range, let's talk, let's see here, domain, range. We kind of already talked about the range, right? I can't wear it, well, 0 times, but I wouldn't want to include 0 because that would make it undefined, right? Or excuse me, yeah. I'd never be able to get to a 0 cost, right? So not undefined, but it would get to that horizontal asymptote of y equals 0. So I'm never going to quite get there. So we'll say from like 0 and then to, let's see here, 100. That seems logical, right? I'm going to include the 100 because that's one wear, it costs $100, right? But I can get close to 0 but never get to 0. So that's like a realistic range in this one. Domain. Let's see here. For domain, I could have bought them and not worn them, right? But I can't divide by 0. So I'm going to err on the side of not including 0. And then we're going to continue on. Could I wear these forever? They're never going out of style, guys. They are never going to go out of style. So I don't know if this is really necessarily the most realistic domain. I think the range is really the most appropriate question to ask here. But for domain, I got to be, a positive number of wears, I guess would be the best way of putting that. Who knows what the lifespan of the shoe may be, of the boot might be. But I do know for a fact that they are never going out of style, right? I'll be buried in those Green Timbs. All right. One more thing that I want to take a look at here is the idea of it like getting close to 0, approaching 0. So let's go back to our table, hit second graph, and oh, look at that. My second function appeared. It's always 0.3. If I continue like this, those numbers are going to decrease, right? They keep getting smaller for my y1 value. The blue value is right there. But that's going to take a while if I just hold on here. So let's go back to table set, and let's like just jump to, say, 1,000. Okay, just for fun here. Just for fun. Funsies. And then I'll hit second graph. And now we're at, 10 cents right there, right? That makes sense. 100 divided by 1,000 is going to give me that 10 cents. And we're getting smaller in the 9-cent range. Let's go back to table set. Let's do 10,000 this time. 1, 2, 3. Second table. And now we're at 1 cent, right? Again, makes sense. We're at 1 cent. And actually, if you arrow over here, it'll tell you like the really precise decimal that we've got. And as you can see, it's just going to keep going down, down, down. One more time. Let's pop another 0 on here. I don't even need to replace everything. Yeah, I mean, we're in the below a penny now, right? That E -4, that means we're going to move the decimal place 4 times. We got 0.0009, right? So that's what, 9/100ths of a cent, I think. I'm trying to do it in my head. Anyways, very small. But as you can see, we're going to just keep getting smaller, smaller, and smaller, and smaller. Get close to 0, but we can never quite get to 0. So we have that horizontal asymptote of y equals 0. Our logical range here, we're not including that 0 because we can never, ever get there. All right. But there we go, guys. That is a little more context into rational functions. I know they're kind of weird. You're dealing with fractions and stuff like that. But hopefully this gave you a little bit of like sense of like why we have the asymptote of y equals 0. that horizontal asymptote, how I can get closer to it, but never quite get there, because no matter what, even if I'm dividing a penny, it still costs something, right? Wonderful. That's awesome. Cool. Right. Thanks for mathing with me, guys. Hopefully this helps and you get a little bit of, stuff with your calculator here. Also, if you weren't getting decimals, I meant to mention this. If you weren't getting decimals at our table here, and when I'm at, like, let's just say 10 here, and you were getting fractions, it's likely because you have this guy right here typed in as 100 divided by X, okay? And if we go to our table, now you'll see the fractions there, right? Because I input it as a fraction, it's going to give me fractions. So I'll do the division, then I get the decimals. If you were actually doing the problem with me, if you're like, nah, man, I'm just watching here. Just watching. This is just great stuff. That's cool too. But if you're ever getting fractions in your table and you're wondering why, that's what it is. Okay, so go back, type in instead 100 divided by X. When we go to our table, now you're going to see the decimals, all right? That's pro tip right there. Pro tip for you dogs. Have a wonderful day. Hope you enjoyed, and stay awesome and dope. See you.